Hi, we're going to take you through total solids now. Before we do that, remember that the measure of total solids is a measure of the particles suspended in the water. And depending on how many things are in the water, even though you can't see them, they're there, this will affect the quality of the water. If there's too much, or if they're poisonous, it's going to affect the quality of life, obviously. And even if they're too small, certain key minerals may be missing. So we're going to take you through that, and as we always do, we'll show you our equipment first and then go through our lab procedure.
Okay, the equipment that you're going to use for total solids, you're going to need 3 clean, washed, and baked dry 400 milliliter beakers that we have in front here. You're going to need a very precise electronic balance that we'll have back in our total solids lab in the room. You're going to need a clean, washed, and baked 100 milliliter graduated cylinder. You're going to need a pair of tongs. Could you show the pair of tongs there? You're going to have that pair of tongs in order to touch the beakers with, because you can't use your hands to touch them. And you're going to have your river water sample that you brought back with you from our field trip. So we have plenty of water to run our tests. And of course, you're going to need your safety equipment, because anytime you work with river water, you want to have your safety equipment on. So before we begin our procedure, it's important that we put on our safety equipment that we told you about earlier.
Protect those eyes and protect those fingers.
Look at that. I am so good at putting these on.
Remember, we're looking at the beakers. We're comparing the mass of the beaker when it's totally clean and sterile, and then when it's got solid material stuck to the side of the glass. So the first thing we have to do is get the mass of these beakers while they're totally clean and dry and there's nothing in them.
One of the mistakes that many students make is they just grab the beaker. Well, every time they grab the beaker, even if they have gloves on or anything, they have a chance of putting, in this case with the gloves on, putting talcum powder on the beaker. And we're measuring things to the nearest thousandth of a gram. And so it can pick up talcum powder. It can pick up any residue that's on there. So it's very important that anytime you handle your cleaned glasses that you use the tongs. So if you'll give me the tongs, we'll take these and we'll have beaker number 1, put that in, and we'll record this down in our lab books.
Make sure when it's resting on the balance that you slide the glass door closed. These are so sensitive, air going through is going to affect your reading. So seal that up, and Mr. Piskel's recording as a good scientist should. That beaker has a mass of 158.661 grams. 158.666.
158.666, correct?
It's actually 158.6663. It's 4 digits.
Okay, we got to 4 digits, so we're going to record to the nearest 10 thousandths of a gram, which is going to even be more precise, so that we can find out exactly how many total solids are in the water. So once we get that, that's beaker number 1. You remove beaker number 1, and you'll do this for 3 beakers, because you're going to run 3 tests to get an average. Okay, now that we've recorded the mass of all 3 beakers, we're ready to add our river water. And what we're going to do is put 100 milliliters of water exactly into each of the 3 beakers, and then evaporate that water off over a 24-hour period. So, Mr. Matthew, if you'll get the river water. Here comes a very tricky part. Mr. Matthew has to measure out exactly 100 milliliters of water in the clean graduated cylinder. And this is our river water that we collected at the river during our field trip. And remember the old trick that you learned in your earlier science classes, that when you measure the volume of water, you always measure from the bottom of the meniscus. He's going to get eye level and look at it and make sure that he has exactly 100 milliliters of water before he gives it to me.
There's exactly 100 milliliters of water in there.
Okay, you can go ahead and I'll move beaker number 1 over there. And we know what beaker number 1 is, dry and clean. Now we're going to pour the water in, and we'll do that for all 3 beakers, and then we'll take them to the oven.
Make sure you're letting it drip so that every single drop of water you can get in there is going to get in there. Some of it's going to stick to the glass, but give it a minute and shake out as much as you possibly can.
Okay, and we'll do that 2 more times, and now we'll go to the oven. Now that we have the mass of the beakers and we've put the 100 milliliters of water in them, we'll put them in our fantastic, handy-dandy oven, which will bake away the water and leave the solid material that is suspended in the water behind so that we can determine the total mass of the solids that are dissolved in the water. And once you put the beakers that have been labeled into the oven, you will turn it on and make sure that it is slightly above boiling so that the heat cycle lamp comes on, and leave them in there for a period of 24 hours, which will be enough time to evaporate the water, and then you'll be ready to get the data tomorrow.
It's 24 hours later. Back to our oven. We're going to open it up. See, our water has been completely evaporated. Remember, you can't touch these with your fingers, so touch them with tongs again. Take them out, and as the instructions tell you, let them cool. And once we've done that with all 3 of them, we'll get their second mass and get the difference between this figure and the mass yesterday. We're back in the lab to get the mass of the beakers now that the water's been evaporated out of them. So we'll take all 3 masses and do some calculating. Beaker number 1, remember to close the door.
Beaker number 1 has a mass of 158.7034 grams. And as you can remember yesterday, when we measured it without the evaporation of the total solids, it was 158.6663 grams. So the mass has gone slightly up because what we have is the remaining residual total solids after we evaporated the water. And now we can figure out, by subtracting what our clean dry beaker was yesterday from what our beaker with the remaining total solids is from the river water today, we can calculate how much total solids were present in the river.
We're going to get the mass of the other 2 beakers and then show you how to calculate with the math to get the absolute total solids.
Once you've collected all the data for your total solids in terms of how much residual material was left in the bottom of the beaker, now comes the fun part. You get to do all the math, and I knew you could hardly wait for that. One of the things that gets me kind of excited is when my data happens to come out well. And in this particular case, our data came out pretty nice, and you'll see why in a moment. Beaker number 1, we started with 158.7034 grams of the beaker with the residual material, and we subtracted the clean beaker from it. It came out to 0.0371 grams of total solids per 100 milliliters of water. In beaker number 2, when we looked at the data from that, it was 157.4194 minus 157.3811, and we came out with 0.0383 grams per 100 milliliters of water. The reason why I'm kind of smiling right now is because I'm looking at the 2 sets of data, and I notice that they happen to be very close to one another, and that's what I want to see. In this particular case, 0.0371 to 0.0383, the difference is very minute. And finally, when I go and look at beaker number 3, there's 158.4258 for the residual material in the beaker minus the clean beaker of 158.3870, and we get 0.0388 grams. Again, a very minute difference between the other 2. This leads me to believe that I was fairly consistent in my methodology in terms of calculating the amount of total solids from evaporating the water off of the river. Our average then of the 3 sets of data, and that's what you'll do with it once you get your three totals, is you'll average them together. In this particular case, it's 0.0381 grams per 100 milliliters of water. And now we're ready to do the next step of calculations for total solids. Now that you have the average for all three beakers, you need to convert this number into the milligrams per liter of river water, because that's what we will use for finding our Q value for the overall water quality. In order to do that, it's a very simple mathematical calculation. All that you have to do is move the decimal point 4 places to the right. In this case, our resulting number is 381 milligrams of total solids per liter of river water. Now we're ready to use the Q value data table chart in order to calculate what our Q value will be for this value of total solids. Now that we've found